So here's a list of all of our fundamental identities that we covered in the last video. We've got our reciprocal identities, quotient identities, Pythagorean identities, cofunction identities, and our even and odd identities. As I said, make sure you have all these written down in your notes and have them handy as we complete the following problems and as you complete the problems in the problem set for homework. It's going to be super helpful, and if you know them, it's going to be even easier for you to do these problems. So let's see if we can't do some examples. Use the fundamental identities to simplify the following expression. So we're going to try to simplify, in this case, the tangent of x times the cosecant of x. And when you read the word simplify, that means we're going to try to get some things to cancel out. And we want to use those fundamental identities that we just talked about. So we need to think critically. How can we rewrite some portions of this expression to get things to simplify? Well, in this particular case, we can rewrite tangent using our quotient identity, sine x over cosine x. The tangent of x is equal to the sine of x divided by the cosine of x. Similarly, we can rewrite cosecant x using a reciprocal identity, 1 over sine x. This gives us sine x divided by cosine x times 1 over sine x. Why does that help us out? Well, notice I've got a sine x in the numerator that I'm going to divide by sine of x. Those are going to cancel, leaving me with 1 over cosine of x, which is a reciprocal identity. I can rewrite 1 over cosine of x as the secant of x. There is my final answer, right? So there's our first example of simplifying a trigonometric expression. Pro tip, and there's going to be a few of these throughout the videos. All right, it is often helpful to rewrite the expression in terms of sines and cosines. All right, tangent x, cosecant x, rewrite each one of those trig functions in terms of sines and cosines. Now, that's not always going to be the easiest way to go about solving the problem, but it can be helpful. Let's look at another one. 1 minus cosine squared x times cosecant x. Well, we have this grouping of a 1 and a cosine squared. Whenever you see groupings of trig functions that are squared, or if they're attached with a 1, think about using those Pythagorean identities. Okay? Think back to your list of Pythagorean identities. We had the Pythagorean identity, sine squared x plus cosine squared x was equal to 1. Well, here I have a 1 minus cosine squared x. We can manipulate this expression so that it says 1 minus cosine squared x by subtracting cosine squared x from both sides. That would give me sine squared x is equal to 1 minus cosine squared x, which tells me that I can replace this quantity, 1 minus cosine squared x, with sine squared x. Now, here we also have cosecant x. We're going to multiply by cosecant x. Using the reciprocal identity, we can replace cosecant x with 1 over sine x. So I now have sine squared x times 1 over sine x. Recall what sine squared x means. That's the sine of x quantity squared, or the sine of x times the sine of x, then divided by the sine of x. Well, I can cancel out one of those sine of x's, leaving me with sine x for my final answer. Pro tip number 2, look for opportunities to use the Pythagorean identities. Recognize that these identities can be arranged algebraically in several different ways. All right, so here was our algebraic rearrangement that we used. We just subtracted cosine squared x from both sides of our equation. All right, let's look at another one here. Use the fundamental trig identities, again, to simplify the following expression. Cosine squared x times the quantity secant squared x minus 1. Well, cosine squared x times secant squared x minus 1. We have this grouping of a squared trig function and a 1. Again, that should get us thinking about using Pythagorean identities. That entire grouping, secant squared x minus 1, can be replaced with tangent squared x. All right? Now, again, let's go back to that Pythagorean identity. Okay? We had our Pythagorean identity, 1 minus tan squared u is equal to secant squared u. We could manipulate this equation by subtracting tan squared u subtracting 1, we get tan squared u is equal to secant squared u minus 1. That's what we had in the expression. Therefore, we can replace secant squared u with we can replace secant squared u minus 1 with tan squared u. All right, secant squared x minus 1 becomes tan squared x. So we've got cosine squared x times tangent squared x. Now we can continue to rewrite our expression. Well, we've got tangent squared x. Tangent can be written as sine over cosine. Therefore, tangent squared x is the same thing as sine squared x divided by cosine squared x. And this helps me out because now I can cancel out my cosine squareds, leaving me with sine squared x for my final answer. All right, let's look at another one here. This is actually the exact same equation. So let's do this same exact problem. Cosine squared x times secant squared x minus 1. Let's do it again. However, let's try a different method. You might have had other thoughts other than using that Pythagorean identity right off the bat. Another way to solve this problem is to begin by rewriting secant squared x using a reciprocal identity. Secant squared x is equal to 1 divided by cosine squared x. So I've got cosine squared x times 1 over cosine squared x minus 1. I can continue to do algebra here. Notice that these are connected by multiplication. And we're all familiar with the distributive property of multiplication. Okay, that just doesn't disappear. We can continue to do the algebra that we know. If we multiply that cosine squared x into the parentheses, that gives us cosine squared x over cosine squared x minus cosine squared x. Well, cosine squared x divided by cosine squared x, any value divided by itself is 1. We have 1 minus cosine squared x, and we can relate this back to our Pythagorean identity. 1 minus cosine squared x, that is equal to sine squared x. So 2 different ways to solve the exact same problem. And notice that we end up with the same answer, which is always a good thing. So this brings us to our next pro tip. In many cases, there are multiple ways to arrive at the correct answer. Use the proper identities and abide by the rules of algebra. If you do that, you're going to be okay. Let's look at a few more here. Sine of x times the cotangent of negative x. So what jumps out at you in this problem? Well, here we have a negative x. Anytime you see a negative inside of a trig function, a negative x inside of a trig function, think about your even and odd identities. Cotangent is an odd function, therefore the cotangent of negative x is negative cotangent of x. We rewrite this as sine of x times negative 1 times cotangent of x. Let's continue to simplify. Cotangent x can be rewritten as cosine x divided by sine x. So I now have, notice I just brought this negative 1 constant multiple to the front. It's nice to have that multiple of negative 1 in front of everything. Sine x, negative sine x, times the cosine of x divided by the sine of x. This helps us because now I can cancel this sine x with this sine x here, leaving me with negative cosine x. Next pro tip. Whenever you see negatives inside of a trig function, rewrite the expression using even and odd identities. Okay, so again, it should be fairly easy to recognize when you want to use those even and odd identities. Do so when you see a negative inside of our trig function, a negative x inside of our trig function. Next one, the cotangent of pi over 2 minus x times the cosine of x. Well, as we mentioned before in the previous video, anytime we see a pi over 2 minus x inside of a trig function, we want to use our cofunction identities. So, to simplify this, all we have to do is rewrite it as the cofunction. Well, here we have cotangent. To get the cofunction of cotangent, I get rid of the co in front. If I take away co from cotangent, I'm left with tangent. That means the cotangent of pi over 2 minus x is equal to the tangent of x. This now gives us the tangent of x times the cosine of x. Using our quotient identity again for tangent, tangent can be written as sine over cosine. This is sine x divided by cosine x times cosine of x. Our cosines now cancel out, and we are left with sine x for our final answer. All right, pro tip, whenever you see pi over 2 minus x inside of a trig function, rewrite the expression using the cofunction identities, right? So that should be fairly easy to recognize when to use even and odd identities, when to use our cofunction identity.